Well guys, this is the third part of vector calculus, and in this video I will talk about the kind of problems in gradient. So first of all, examiner will provide you this kind of equations fxyz equals to c. For generalizing, I'm talking about fxyz. Maybe he or she will give you kind of x equals to y square, something like that. So however, in that case c is 0 and fxy comma z is nothing but x minus y square, right? So how we can proceed? We just have to do this, what I have done this thing, and then we just have to do a simple this, and we will get our gradient. But if you can do if you can find out the gradient to graphical approach, then it's also good. Like in that case, first of all, the first approach, method 1, let's say method 1, I have told you, first of all just look at the equation and generate the equation of phi. This is fx comma y comma z is equals to what? X, and c is c. So phi is nothing but plus minus f minus c, right? Plus minus what? F minus c, right? Now f is what? X minus c. Now simple del phi, this is vector, and now what is del? Del is nothing but this plus del by del y j cap plus del by del x, sorry, del z k cap. Now there is no term for y and z, so only 1 into I cap. I am writing, sorry. Okay, there is no term for y and z, so I am writing directly. This is nothing but 1 into I cap, so I cap, right? But there is a plus minus, so it will be plus minus I cap. It will be plus minus I cap. This is x, not f actually, right? So this is plus minus I cap. This is the method 1. Now you can do what the hell, man. Well, you can do a kind of second method is there, method 2. What is method 2? Method 2 is saying we can operate through graphs. Wait, so let's say this is the 3D space or coordinate system, and this is x equals to c. So what does it mean? This, let's say this is the point x equals to c. So this is nothing but a sheet, infinite sheet, because let's say this is x, this is x axis, this is y axis, and this is z axis. This is c, this point is c, x equals to c. This is an infinite sheet. Now basically I have told you the gradient is nothing but the perpendicular vector at a particular point. In the particular point, let's say c. Now this sheet has two perpendicular vectors at the point c, something like that and something like this is I cap and this is minus I cap. So minus I cap and plus I cap would be the the gradients. So in that case, plus I and minus I would be the gradient according to graph, and according to mathematics this is also same. So you can go through graphs, you can go through method 1 or method 2, it's your choice, but I will prefer method 1 because examiner will not give you this kind of equation. Examiner will give you kind of that x cube, this is not cube, x cube y plus yz square plus z x to the power 7 by 2. Let's say I'm just making it complicated so that you can't plot the graph. Jokes apart, but if you can, if you are a genius, in that case, maybe you can go through graphs, but I will suggest you method 1, the simple, do the differentiation or partial differentiation so that you can proceed. So in that case, if this is the equation, how we can proceed? If this is the equation, how we can proceed? Let's say phi is equals to this. In that case, point to be noted, there is no constant. There is no constant. That means examiner is giving you the phi, not f. Even it is not phi, it is, let's say, f. In that case, it is also given that we are mentioning you. We are giving you the phi actually, because there is no constant. Don't tell me like constant is equals to 0. No, that is not true. The equation will be given in that format, f equals to c, where c is constant. But in that case, you can say like c is not constant, c is a variable. No, c can't be a variable, right? So however, this is phi, so you just have to do simple operation with the nabla operator so that you can get the gradient, right? In that case, if I am finding out the gradient, then derivative with respect to x is equals to 3x square. This will be 0, this will be plus, sorry, there is a y, plus let's say this is 7 by 2, this is z, this is x to the power 7 by 2 minus 1, which is nothing but 5 by 2, right? Maybe my calculation is correct, into I cap. I'm doing it simple. What is happening, I can't understand. However, so I'm doing it in a simple way. I'm just doing simple differentiation, right? Plus for y, this is y, this is y, so this will be 0 and this will be like x cube, and this will be z square, x cube plus z square, and this is j cap, very nice, plus about z, so this will be 0 and this will be 2yz, plus this will be x to the power 7 by 2. Very nice. This is k cap. Wait a moment, I don't know what is happening, but I guess someone is here, some kind of ghost or something like that. Goodbye, ghost. Please don't disturb me. I am doing mathematics. If you are disturbing, I will use dy by dx, because you are a constant, so you will become 0. So please don't disturb me. So however, thank you. So this is the gradient, even ghost is trying to understand what is gradient, but you are not. Jokes apart, however, so this is the gradient, and you can easily find out using the mathematics, but you can go through graphs also. As I've told you, if you're a genius, then you should go through graphs. It will like create a very deep concept about the gradients. So however, this is a kind of simple, very, not such a simple, but kind of example. So however, this is about this video. In the next video, I will talk about direction and derivative. Thank you for watching my videos. Goodbye.